Okay, so picking back up on number 50, just to reiterate, we had these two equations, and it says solve by substitution, but you can solve by any method you want. But I'm demonstrating here solving by substitution. You would solve for the easiest variable x by throwing the other term across the line. That solves it for x equals 3y minus 31. Then you can sub that in for x, because they're interchangeable, into the other equation, giving you this, which then you can solve it. It makes it solvable because it only has y's in it. So now it's something we can solve. Whereas it did have two variables, now it just has the one variable y. So you do your magic there, solve it, get y is 9. That's half the answer. You need x and y solution. So now that we know y is 9, we can plug 9 in for any of the former y equations, here, here, or here. I chose this as the easiest place, x equals. So it's already solved for x, you know, and I'll plug in y is 9. That's 3 times 9, 27 minus 31, which is negative 4 for x. So that should be the place those two lines would cross if graphed. All right, moving on to number 51. 51 has layers of complication in it, but it is really the same thing we did there. We're trying to solve this system. But in this problem, we get to test you on some old skills about how do you clean up the fractions. You've got to clean these equations up first before you can do this to it. So we need to make them in standard form. So the first thing is the fractions need to go. Anytime you see a fraction in an equation, that is your first reaction. You got to get rid of the fractions. So in this equation, I've got a 5 and a 10, and that's over 1. So the LCD is 10. So I'm going to times each side of this equation by 10. And then that 10 distributes. 10 distributed is going to be diagonal, and it's multiplying. When you distribute, you multiply. So diagonally, you can cancel out the 5 and the 10 cancels to be a 2. So we just distribute 2 here, and it's 2x plus 3. Then I go back to the 10 and distribute it onto the next term. The 10s fully cancel out, and you just bring this down. And then lastly, the 10 distributes here. The 1 does not cancel any of it out, so it's the full 5 times 10, or 50. So then we want to clean that up. It's better now without the fractions, but we can distribute and put that in standard form. So we've got a 2x and a minus x and a 2y. Then this 6 I would take to the other side, making a 44. And that's what I would call now in standard form. So that's equation 1. So I'm going to put that over here to the side and say I've got the first equation cleaned up.
When you did the distribution, why would it be 2x plus 6 at the top?
I could have up here, so the question is whenever I cancel the 5 and the 10, I get a 2 on this first one, and then I would distribute the 2, and it does wind up giving me the 6. I just hadn't distributed it yet when I first wrote it down.
Okay.
You could distribute it as you go or wait and distribute it.
Okay.
But yeah,
Sorry.
yeah, you should get a 6, yes. Okay, other questions? Okay, now do the same thing to this next one. It's the same process. I'm going to erase that. So notice the LCD of 4 and 5 is 20. We're going to times each side by 20 this time to clean it up. When we distribute the 20, the 4 and the 20 cancel to be a 5. So we can distribute as we go, and as a matter of fact, it kind of saves time, so I'll just do that. 5x and 10. Then we're going to use the 20 again and distribute it to the second term. This time the 5 and the 20 reduces to a 4 that will be distributed. And it is a positive, so 4 times positive 3 is positive 12y, 4 times 4 is 16. And then lastly over here, 20 has to be times to the other side, keeping that balance. So 20 times negative 3 is negative 60. So that's the magic that gets rid of the fractions. Then we want to standard form it. We've got a 5x and a 12y. They don't have any other counterparts, no other variables. This 10 and 16 I'm going to take to the other side, minus 10 and minus 16. Combine all those just constants, is negative 86. And now that one's in standard form. I'm going to call this equation 2. Okay, so up here, I'll put those vertically sort of to see what I've got. 5x and 12y is negative 86. So all of that was just to get it cleaned up to where we were on our last problem, number 50. Now what do we want to do here? Do we want to use the addition method and try to get something to cancel down, or do we want to use substitution? It's set up well for substitution like the last one. Since that's a 1x, I would say it's set up well to use that. So you can do that method again, but I'm going to demonstrate the addition method here. To add, I either need the x's to be opposite or the y's to be opposite. It's your choice. I'm going to focus on the x's. To get the x's to cancel, I need this times through by a negative 5. I have to do the same thing to all the equation to keep its balance. So equation 1 times negative 5 would look like this. Then equation 2 doesn't need any prep done to it. It's already going to work to have opposite x's there. Sometimes you have to do something to both equations, but not on this. So then when I add down, the x's cancel as our design was. Negative 10y and 12y is 2y. And then that's negative 306. Then we can solve by dividing by 2 on both sides. Negative 306 divided by 2 is negative 153. Negative 153. So that's the y value. Remember, you need an x and a y. So then you go back up here and find the other counterpart. By plugging in y is negative 153 for either one of the y's. This equation seems a little easier, but that's your call. They'll work in either place or even in its other forms. So we plug in y is negative 153 and then solve away. So that becomes x minus 306 equals 44. And then we need to plus 306. So x is 350. So those numbers seem wrong, but I think they're right. We can check the answer key and make sure, is that a choice? It's always bad when you work it out. It's not a choice, right? But it is. It is choice B, you'll find. X is 350, y is negative 153. Now, if we want to be sure, say there weren't choices there, and even when there are choices, sometimes they psych you out because it doesn't mean you didn't make a mistake. So you do need to check if you want to be absolutely sure. We go back into the problem and say, is 350 plus 2 times negative 153 equal to 44? It's not a long checking process, so I really encourage you to do that. And then check it in this one as well. So take a minute and please do that on test day. All right, questions on that? Okay, I'm going to skip 52 for the moment and come back to that in a little bit. I'm going to go down to number 55 and do some of the nonlinear examples with the same 2 methods. We can use substitution or the addition on those as well. So really nothing new here, just the equations might look a little different, but stuff that we've seen before. Okay, so looking at number 55 next. So this time, like I said, they're nonlinear, so this would go along with your 5.5 stuff. This is actually a circle. We did this one earlier in chapter 2, earlier in the class, and we said when you have x squared and y squared equals the radius squared. That's not a perfect radius, but it is going to be a circle. And then this is a line, of course, just x minus y is 1. So we may have a circle with a line going through it some way, so there can be 2 intersection points in that case. Now, all of the ones that we're working in the study guide, they all work out to have a solution, but if you're doing your homework back in some of maybe the bonus work on MyLabs Plus or something, you'll find that that sometimes you don't get a solution. You work it out and it could be a circle and the line's underneath it. So sometimes there's no solution. Now what that looks like, if I did all my process here, is the variable drops out and you might get like 7 equals 350, some false statement. So that can happen. You don't always have solutions. But anyway, these do, so we should expect to find their crossing points, and in this case, it is going to cross twice. We're gonna find two answers. All right, so addition would not work well on this one, so adding down x squared and x are not like terms, and y squared and y not like terms. So I really can't use the addition method on this anyway, so I need that substitution method sometimes. I would solve for this 1x by throwing the y across the line, and then use substitution process means you take whatever it says x is equivalent to and you plug it into that variable in the other equation. You sub it for that variable. So then this x becomes y plus 1, and it is squared, plus y squared equals 13. And then that's the equation we have left to deal with. Notice why this works is now you have just one variable in your equation, so there's one answer to it. Or actually, it's going to be a quadratic, but it's solvable now. The thing I would remind you of here is y plus 1 squared is not just y squared and 1. You will get middle stuff. You can either do that by the FOIL method, knowing that y plus 1 squared means times in it by itself, which when we FOIL that, we find out we get a 1y on the outer and a 1y on the inner. Or you can just remember when you do this, the shortcut is you get two y's. You do get the y squared and the 1 squared, but you also get the middle terms times together and double. That's the squaring pattern. Sometimes we forget that middle part, so I just wanted to remind you. Then we've got plus y squared equals 13. So this is a quadratic equation. Because of the y squared, you can combine these. That makes 2y squareds, a 2y. And what I was going to say is because you've got y squared, it's a quadratic equation, which means it's all going to come to one side. Quadratic standard form, the squared term, the first term, and then the constant equals 0 must be in that form to solve. Then from there, some of y'all like the formula. You can do your ABC thing and plug it in the quadratic formula. I'm a factorer, so I'll probably factor it. Whichever way you're going to do it, I see everything divides by 2, so why not do that and make your numbers easier? So everything divides by 2 evenly, and then that reduces our equation a little bit. And then factoring would be easier now that you've got smaller numbers. That always helps with factoring. The smaller the numbers. It's just a y and a y is the only way to get y squared. We need a plus 3 and a minus 2 to get the negative 6, and it FOILs to give the correct middle term. Set each factor equal to 0, and we do get two solutions. Because it was a quadratic, it comes out with these two different y values. So like I mentioned earlier, because these nonlinears, they can cross in more than one place. So we've got two y values that we need to find x values for, so do it one at a time. I'm going to take y as negative 3. You can go into any of the forms of the equations, but in substitution we always have this nice place here, x equals already solved for, so I plug in negative 3. In that case, when y is negative 3, x is negative 3 plus 1, or negative 2. So that's a point. X is negative 2, y is negative 3, one of the solutions. And then do it again for y is 2. So back here, again, you could go to any of them, but this is the easiest place to plug in y is a 2. X will be 2 plus 1, or x will be 3. So when y is 2, x is 3, that's our other point. So those are the two intersecting points for that equation. Okay, thoughts on that? How are we doing on time?
14 minutes.
We better stop it